take you through a hands-on lab demo of how we can do Bitcoin predictions using machine learning. Before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, to let us know in the chat section so that we can resolve them. I'm repeating again. Before we start, I hope the screen is clearly visible and the audio is fine. Please type in yes. If there are any issues, to let us know in the chat section so that we can resolve them. Let's wait for some more minutes to let other people join. Until then, let me tell you guys that we have regular updates on multiple technologies. If you are a tech geek and a continuous hunt for the latest technological trends, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any update from Simplilearn. I think we can get started. First, we will write the command to open Jupyter Notebook. So here I will write Jupyter Notebook, press enter. We will open, taking time. Jupyter Notebook is open. So here I will go to Python 3. Just here I will write Bitcoin. So let's import some like needed libraries for this project, Bitcoin prediction project. So here I will write import NumPy. Then I will write import Pandas as I will set the style as white grid. Okay. Matplotlib pyplot as plt, and I will write plt dot style use this is the one of the style in it. For some major from Keras code sequential. We go in details, so stay from code early stopping. And from Keras here's code which is dense, comma LSTM from sklearn dot okay. Press enter. Let's see. Is not found. Found in the library style libraries and input is not valid or URL path C style not available. work. Okay, still loading. Let's wait. Okay, callbacks import early stopping. S should be capital. Yeah. So NumPy is a Python library used for working with arrays. It also has a function for working in the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. And the second one is Pandas. So Pandas is a software library written for the Python programming language for data manipulation and analysis. In particular, it offers data structure and operation for manipulating numerical tables and the time series. Seaborn, an open source Python library based on Matplotlib, is called Seaborn. It is utilized for data exploration and data visualization. With data frames and the Pandas library, Seaborn function with ease. Then this Matplotlib, Python and its numerical extension NumPy. Matplotlib is a like cross-platform data visualization and graphical charting package. As a result, it represents a strong open source substitute for MATLAB. The APIs for MATLAB allow programmers to incorporate graphs into like GUI applications and all. Okay. Then this LSTM. LSTM stands for Long Short Term Memory Layer, which created in 1997. This layer uses available constant and runtime hardware to gain the most optimized performance, where we can choose the various implementation, that is pure TensorFlow, or you can use CDU DGN. Okay. Dense. A dense is a layer that is deeply connected with the preceding layer, which means the neurons of the layer are connected to every neuron of its preceding layer. This layer is most commonly used and in the artificial network, neural networks. Okay. Let's see the earliest topic. Okay. So early stopping is a form of regularization used to avoid overfitting when training a learner with an iterative method, such as gradient descent. So such method update the learner so as to make it better fit the training data with each iteration. Okay. So this min-max scaler. Min-max scaler transforms feature by scaling each feature to a given range. This estimator scales and translates each feature individually such that it is in the given range on the training data. Okay, that is like between 0 to 1. Let's move forward and update the reading data. Let's read the data. So for that, I will write like data name BTC. You can download this file from the description box below. Okay, and you can also comment for the full code in the on the comment section. I will provide you the all the code. DF. So so here PD is for like pandas library and read is for reading the data. CSV is the file type. Okay. So let's see the data first. So for that I will write df dot head. Df dot head is used to show the top 5 rows of the particular data set. Okay. If you want to see the last 5 rows, you can use tail instead of head. Tail instead of head. Okay. These are the last 5 rows. These are the last 5 rows. Okay. Got it. Let's move forward and do like Python function for the dataset. So I will write here df dot the information about the dataset. Okay, here you can see we have column name, unnamed, currency, date, closing price, 24-hour open, and then high price, low price. Okay, then here you can see the number of value 2787 in particular column, and here you can see no null count here, and data type you can see here unnamed is in integer, and this currency and date are object, yeah, object one, and these four are the float one. Okay, so here gives all the information about the set. So moving forward, f dot describe. What describe do? Describe show you all the statical like value from the data set for the particular column. Okay, that count number is like 2787. The mean of unnamed column is 1393, and the standard deviation, then minimum value is 0. Then what is the 25% of particular column? So it is like the maximum value. So this is for the all the columns 1, 2, 3, 4, 5. Okay, moving forward, let's set date column as an index. For that, I have to write here date df to date time at index date. So what I will write true or true. Why? Because true, because you have to like you want to change in a particular data set. Okay. So let me press enter. Forward. Let's see the opening and closing prices of Bitcoin using a graph. Okay. For that, I have to write TLT dot figure. Okay. And figure size equals to 15 point. Sorry, 15. Okay. Then DF dot and same for this one also. Okay, so I have to add one. So here I will write let's set let's set the y label plt dot y label plt dot title name plt dot legend name open price dot tight underscore layer dot show. Ah, is it working or not? I don't know. Okay. Don't sing, guys. As you can see, the opening and closing price, okay, of the particular Bitcoin, price of the Bitcoin. Let's move forward and let's see the high and the low price of the Bitcoin in the 24 hour. Okay, for that I will write plt dot figure the size in comma 6. Same. So like repeat. So let me copy from here and put it here because the thing will be almost same. Just I have to change here 24 hours price and here I can write high and low point for R. Okay, here I have to write high price, low price. Okay, so let me see the graph. So as you can see, the high price and the low price of the Bitcoin in 24 hours. Okay, the blue one represent the high price and the red one represent the low price. Okay, so moving forward, let we will do the I repeat, data pre-processing. Okay, let's do data pre-processing and let's choose the prediction column first. So for that, I will write n underscore calls equals to 1, then data set equals to df price data set equals to dot data frame data equals to data set dot data dot shape. So after this, we will do the normalizing of the data. So for that, I import from sklearn already discussed what is min max scalar. Okay, so moving ahead, we'll write a scalar to min max scalar the underscore range 0 comma 1 scaled underscore data equal to scalar dot fit transform p dot np dot array. This is from the NumPy, then data. Okay, presenter So the data. So what we will do, we will split the 75% data to the training part and the 25% to the testing part. Okay. Train underscore to end data. Okay. So after that, this is for the training data. Okay, 75% size. For the testing, we'll give the minus training size. Length of the data is like 100%, so 100% minus 75% is 25%. So test size is 25%. Okay, so in size, okay. Then again we'll print test size. As you can see, 2090 is the training data. For the training size, you can say, and the test size is 697. Moving ahead, let's see. Let's train data equals to scale data train underscore size train underscore. As you can see, there is like 2090 rows and one column. Okay. So moving forward, let's create training set. Okay, for like training set with 60 time steps. So for that, x underscore train y train equals to 60 false equals to 1. Okay. Here I will write for I in range training data colon here, then x train train underscore data I minus time I and false. Like same like phi train dot training data I comma I comma if I is less than equals to times int underscore train underscore train. Okay, and y and okay, then presenter. Okay, training. As you can see, the X train the array. Okay, now we will convert to NumPy array. This thing to NumPy array. So X underscore train. Train underscore train, comma np dot array. So after converting into NumPy array, let's reshape the input to like n samples, time steps, and the n feature. For that, x underscore train equals to np dot reshape underscore train. The size should be 0. Shape. So now let's see the size x train dot shape for train. As you can see, the X train is 203060 and column is 1. Then in Y train, there is no column. So, okay, there is no like X train shape. Okay, got it? So, moving forward, let's create the model, LSTM model. Okay, for that, first we will get the model structure. So, for that, I will write model equals to sequential. Okay, LSTM and I will write 50, comma return. Okay, then input to x underscore train dot shape for here LSTM again 64 and hence 22 and And here I have to write model file manager Adam. Let's see. It's cute. So as you know, LSTM is stand for long short term memory layer. Okay, this layer uses like available constraint and runtime hardware to gain the most optimized performance where we can choose the various implementation. Okay, and this dense is a layer that is deeply connected with the preceding layer before one. Okay, which means the neurons of the layers are connected to every neuron of its like preceding layer. This layer is most commonly used layer in artificial neural networks. Okay, so these are the number of layers as you can see 32, 16, and 64 and 50. Okay, so here I will write, let's see the summary of the model. Okay, these are the parameter, then output shape. Yeah, so moving to the model. Okay, like fitting the LSTM to the training set. Okay, we have created this model LSTM. Now we are fitting into the training set. Okay, so for that I will write history model dot fit underscore train comma in comma box should be 100. So it will take time and batch size equals to 32. Batch size equals to 32. One train and then epoch equals to 100. So we can do epochs 10 or 50. No, 100. Is another model dot fit got unexpected epochs. Yeah. So it will run till 100. So it will take time. I will get back to you then. Okay. So it is done as you can see here. Like 100 epochs is done. So moving forward, what we will do, we will create. Okay. So we will do model evaluation. Okay. So for this, we will create this graph, like how many losses, how many epochs. Okay. So what I will do, I will just paste it here. Okay. So yes. So this is you can see the losses. Okay. This is mean squared error. So moving forward, let's do the prediction now finally. So for that, first I will make it. First, we will like creating a testing data set with the 60 time steps and one output, like we did for the training one. For that, I will write here time steps equals to 50 and data equals to scale data for test y underscore test or I in range length of like test data underscore test dot append. We did for the training one before, then test data apps I, then colon n underscore. Okay, then y underscore test dot append data colon n underscore calls. Okay, so now what we will do, we will underscore test comma y underscore test plus x underscore test comma test. Okay, so np dot shape x underscore test comma underscore test dot shape and 0 shape 1 comma n underscore calls. Push. Okay, there is an error. Test data append y test. Data train size. Sorry, my bad. Good. Array. So let's do x underscore test x underscore shape comma y underscore test dot shape. Okay, so these are the testing. Okay, for the test is at 25%. So now get predictions. So predictions dot predict. Now inverts the prediction scaling. So for that I will write predictions to scalar dot 97 column 1. Okay, now we will do the root mean square error. So inverse like y test scaling. So for that I will write y underscore test was to scalar dot form y underscore test. Okay, RMSE root mean square error. So equals to np dot error to 2 dot round to 1270.45. Okay. np.sqrt, np.mean, white test, minus predictions. Okay, into 2 round 2. Yeah. Here I will write pd dot data frame. Then here I will write predictions. Comma. I can write here like actuals and dot y underscore test dot flatten. I will do, I will for x. These are the like actuals values. Okay. So now we will plot a graph of like predictions, kind of prediction versus actuals, you can say. So let me just, I will write here plt dot figure is equals to 16 comma 6 and plt dot plot x. Okay. Plt dot plot plt dot legend graph. There's an error predictions. Okay, what's the spelling here? Copy it from here itself. You can see the blue one are the predictions and the actuals are the those one. Now let's see the visualization of the predictions with the data. Okay. So for that, this is the final graph. You can say train equals to dot ilog log then size. Okay, 0.1. Then test equals to data set log colon 0 test then equals to size should be 3, comma 6. plt dot title point of predictions font size was 20. So let's set the x label and the y label. Dot x label 8, comma font size again dot y label rows size font size equals to 18 and plt dot plot size, comma line width and copy it is for the test. Right here dot test let me copy it from here. So comma line width plt dot legend then right here just comma and let me debug the error. Okay. As you can see, the training test and prediction values, and the yellow one is prediction. This is the final output of our this project. This is the final output as you can see, and if you want this full code you can comment for the same, and to if you want to download the dataset, so you can download from the description box below. I hope you guys understand how we can predict Bitcoin using machine learning or deep learning, you can say. So you can ask in the comment section below if you have any queries. Our team will respond to you as soon as possible. Don't forget to subscribe to our YouTube channel, and you can check the similar courses links in the description box below regarding the machine learning and all. If you want this full code, just comment for the same. And thank you so much for being here. If you enjoyed this video, please subscribe to our YouTube channel and press that bell icon. Okay, till then, thank you and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.